Right, so good morning, good afternoon, good evening, wherever you all are. Dear authors and invited guests, it is my great pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 and Global Knowledge Research Foundation. As every one of us is passing through unforeseen circumstances due to COVID-19, we wish everyone and their families a safe time. Further, with immense happiness, I would like to share that we have received an overwhelming response this year from across 90 countries where 1,150 papers were received and 350 papers were accepted, contributing to the success of this conference, and the papers will be published in 4 volumes this year. We are thankful to all of our guests present on this platform to join us digitally for the conference in these unpredictable times and make this conference more fruitful in terms of technical knowledge, and I hope you enjoy the 2 days of the knowledgeable and interactive sessions. So I'd like to welcome you to technical session number 7. And I'm just going to briefly introduce you to our chair for this session, which is Melis Kitsing. I'm sorry if I've mispronounced your name. I'm just going to tell you a little bit about Melis. So Melis is the Rector of and Professor of Political Economy at the Estonian Business School. Previously, Kitsing worked as Head of Research at Foresight Centre, a think tank at the Estonian Parliament, an advisor at the Strategy Unit of the Estonian Government Office, and Head Economic Analysis at the Estonian Ministry of Economic Affairs and Communication. He also served as the President of the Estonian Economic Association. Kitsing's current research interests focus on political economy of digital platform ecosystems. His research has been published by Transnational Corporations Review, Journal of Politics, Policy and Internet, Journal of Information Technology and Politics, as well as by Springer, IEE, ACM, Leuven University, and MIT Press. So now moving forward, we would like to invite the first presenter to start. I'm not actually sure if they are in the session, bear with me. So to begin with, for the first presentation, which is User Experience Framework for Teachers Using Mobile Technologies in Resource-Constrained Environments. So I don't actually have a first name here, but it's Mrs. McCalmer. Is Mrs. McCalmer here? Doesn't appear so. If anyone is here in place of Miss McCalmer to present this presentation, please could you let us know by turning on your microphone or just simply saying in the chat.
I am here.
Oh, right. Okay, nice one. Okay. Yeah, I can hear you. So sorry about that. If you'd just like to, start presenting if you're ready to, whenever you are.
Okay. Here it says the browser is preventing what? I'm trying to share the screen. The browser is preventing access to the screen. I'm trying to share the screen here.
Yeah, if you at the bottom of the screen, there should be a green icon, so share screen, and then.
Yeah, I've done that.
Sorry, say that again. It cut out.
Yeah. Your browser is preventing access to your share screen. I don't know.
Have you got the document downloaded?
Yes, I do have the document.
Okay, if you open it, if you open the said presentation and then click share screen, then hopefully under whiteboard it should come up with all of your different all the different things that you have open. So you should hopefully just be able to click it instead of opening it as an individual file. A few people have had problems opening there, so don't worry. I'm sure it'll be resolved soon. Okay, so unfortunately the chair there. Go on, carry on.
Can I try to reconnect again, because it still says
yeah,
can
that's
I leave
fine.
and
Yeah, that's fine. I'll accept you back.
Okay.
We're just going to wait for Miss McConnell to connect quickly, and we'll give her another go quickly because I said I would let her back in. Sorry about this, guys. Right, okay. It does look like we're having a bit of a problem. So the next presenter, presenting on profiling space reduction efficiency in vector space modeling based natural language processing. This is to be presented by Aladdin Ben Aid. I believe you are in the call. I see it. I'm just going to request to unmute you, Aladdin.
Yeah, hello.
Yep, I can hear you good.
Okay, perfect. So I'm gonna share my screen and actually I'm ready for the.
Yeah, hopefully you have a bit better luck.
Just a moment, please give me. Okay, I'm coming.
Yeah, we can see yours. All good to go.
Okay, perfect. Let me please activate my cam just to. Okay, just one moment. Okay, hello everyone. So I'm Aladdin Ben Ayed. I'm a student, PhD student at UQAM, Université de Québec and Montreal. And today I'm going to present our contribution entitled on profiling space reduction efficiency in vector space modeling based NLP. So actually, we're going to start by a small introduction, then we will state our motivations, our methodology. We will also state experimental results and final concluding remarks. So actually, the paper is taking the subject of space reduction, and space reduction is used in a bunch of applications, industrial and research applications such as image recognition, like face tracking applications, biomedical research and industry, speech recognition, and natural language processing, either in automatic translation or summarization. And actually, summarization is going to be the use case for this research. Our objective is to profile the space reduction efficiency in what we call vector space modeling, natural language processing. And as I said, we're going to use the automatic text summarization as a use case. So the goal here is to investigate how the user technique of space reduction is going to impact the quality of the generated summaries. For this, we're gonna make a comparison between results obtained with a linear space reduction technique and a nonlinear one. Let me describe a little bit the proposed protocol for text summarization. At the beginning, we have an original text, then we apply vector space modeling, either the linear technique or the nonlinear one, in order to generate two measures, one of coverage or retention, and the other one is fidelity coefficient, okay? Then we inject those metrics in a fuzzy system. So we use fuzzy logic in order to combine those two metrics and generate what we call the fidelity coverage coefficient. Then we take sentences which have the highest scores of fuzzy fidelity coverage coefficients, and we extract them to generate the final output, the summary. So by the end, it's what we call a by extraction text summarization protocol. And what we are doing in this research is profiling the impact of using either a linear or non-linear space reduction technique when making the vector space modeling in order to generate what we're gonna call the conceptual space. So let's move to technical details. And as I said, we will compare two methods: the PCA, which is a linear method of space reduction, and the isomap, isometric mapping method, which is a nonlinear one. In both methods, we proceed in the same way. We first extract sentences of the original text. Then we create what we call the dictionary or the lexem. We represent each sentence by a feature vector. Then we compute what we call the mean concept or the mean feature vector. We use it actually to normalize each sentence. So we subtracted from the feature vector of each sentence in order to get rid of redundant information. Then we compute the conceptual space. We construct the conceptual space. For this, we first compute the covariance matrix. And then, I'm not going to go in deep in the details of the construction. I will keep that for the question session. But the main idea is that we try to find the principal components or the eigenvectors of the covariance matrix. And for that, we apply what we call the single value decomposition. Then eigenvectors associated to the highest eigenvalues, we're going to take them and they will construct what we call the basis of the conceptual space. Why would we take those vectors? Because actually they are the vectors that encode most salient information in the original text. So we construct what we call the basis of the conceptual space. Then we project each sentence of the original text to this newly constructed space, and we compute the distance between each vector of the basis of the conceptual space with all the projected sentences onto this newly constructed space in order to construct what we call the retention fidelity tensor. And here, for example, here is the index of the sentence, and here is the distance to the feature vector, to the vector encoding the most important concept. So the vector that is the first eigenvector that is associated to the highest eigenvalue. Okay, this is the index of the second sentence that have the nearest distance to the vector encoding, so the first eigenconcept, etc. So the order here of the sentence is depending on the distance to a given concept. And if we go by these, by columns instead of lines, so here is the second eigenconcept, the third eigenconcept, etc. So we use this tensor to construct two metrics. The first one is the coverage or retention metric, and the second one is the fidelity metric. And the intuition behind the coverage metric is that sentences with height coverage score should encode as much as possible most important concepts. Okay, this is the first thing, and the retention and the fidelity metric, actually it has the same intuition, but we add to that we take in consideration, excuse me, that we take in consideration the importance of the concept. Okay, so that's why we make a ponderation. If you have questions, please ask them during the question section. So after that, we take, as I said, the sentences which have the highest scores of retention fidelity. And here I skipped many diapos due to the restriction of times, but I can explain later how we can generate the fuzzy scores. Okay. That's all. So it's by extraction summarization protocol. We take the sentences which are associated to the highest fuzzy coverage and retention and fidelity scores. The second method, actually, it's based on, instead of PCA, instead of using PCA principal component analysis in order to construct the conceptual space, actually we use a nonlinear method, which is the isometric mapping based, method. In this method, actually we construct K nearest neighbor graph of endpoints, and we compute the shortest path between all points as an estimation of the geodesic distance. Then we construct the conceptual space by making a single value decomposition of K.
Sorry to interrupt, got 2 minutes left.
Yeah. So for experiences, actually, we used the timeline database, which is a database, and we used the Rouge score in order, actually, it's the metric that is usually used to evaluate the quality of the generated summary. And there are many variants of Rouge. There is one which works with 1 gram, 2 grams, or with skip grams. And as you say, the ISOMAP protocol of summarization gives better results. Then actually we try to understand why, and that's and we performed a study of sparsity. Here I have small graphs, but actually here is the sparsity of the constructed space. Okay, so here in blue is for the initial space, in red for the PCA space, and in with green, actually green is in this line, okay, is for the isometric method. And as you see, the sparsity of the constructed space with the isometric with ISOMAP is less than the sparsity space of the space constructed by PCA. And here we have a comparison between PCA and ISOMAP. Actually, the sparsity of the space with ISOMAP is smaller than the sparsity of the space that is generated by the PCA method, and that's actually due to the fact that the PCA method is a linear method, so it uses the Euclidean distance, but the second, the ISOMAP method uses the geodesic distance, and which simulates better the space. So as a conclusion, we can say that nonlinear space induction summarization approaches outperform, excuse me, the linear space inductions one. Also, we noted actually that the recent natural language processing literature is using different NLP methods which are still using linear space induction techniques. So the obtained results of those papers can be improved by merely using a nonlinear reduction technique instead of linear ones. Thank you, and we go to the question session.
Right, thank you for that. Unfortunately, Milas's audio is not working, so I'm just going to ask on his behalf. What are the potential applications of this paper?
So actually, this paper, the funding of this paper is important for any kind of application that was done in signal processing. When I say signal processing, it can be text processing, so NLP, as I said, translation, summarization systems, etc. And the literature demonstrates that new methods that were proposed in 2019, for example, are still using linear methods. So actually, obtained results can be improved by simply using non-linear methods instead of linear ones, especially in the context in the context of NLP and in the context so we did the proof in text summarization. I think it's going to be the same thing for translations.
Okay, thank you for that. Right, I imagine that is all for now. So moving forward now onto the next. Okay, moderator didn't for me. Okay, so yeah, thank you for that, Aladdin. So moving forward, now we are going to go to Rubeya. I'm sorry if I've said mispronounced that. He'll be presenting building a conceptual model for the acceptance of drones in Saudi Arabia.
Yes, hello everyone.
Hello.
Sounds clear?
Yeah.
Okay.
Yeah, we can see your screen now, so you're good to go.
Yep. Hello everyone, my name is Rubai. I'm an associate professor at the Department of Computer Science at Taif University in Saudi Arabia. The title of this presentation is about the building a conceptual model for the acceptance of drones in Saudi Arabia. Just trying to find the Okay, this is the outline of this presentation. If you can just move to stick the time of 10 minutes for presentation. First of all, we're going to start by literature review or background. Definition of the drones. Drones have many of definitions. Well, and one of these definitions is they are aircraft capable of flying manually or operating independently over the predetermined flight plan and returning to the departure point after the completing the mission. Okay, what's the motivation? The first motivation of this research, this comes from the importance of the drones. So drones have become the focus of academic industry, and commerce. And the reason for this importance is their strength. So drones have characteristic attributes such as mobility, flexibility, and adaptivity, and different attributes. And however, it still have some problems or weaknesses compared to conventional base station. They have limited to reliability and coverage and energy resources. The second point is the architecture of the drone. Drone doesn't have specific guidelines for architecture, but in general it consists of three main components, which is the frame and propulsion systems and flight controller. During the extensive literature review for existing drone modeling methodologies, we highlight the key of the common parameters and limitations of the drones in general, which is the connectivity and human operator and motion and flight range. So for connectivity, the drones must receive communication relation with the ground control station in order to collect instructions and transmit the information gathered. And regarding to the human operatory, in many countries, drone regulations require a human operatory. Typically, for human conducts a variety of set of actions prior to the launch of the drone and following its landing, and may have to monitoring the drone and analyzing the information gathered. And for the motion, drone can travel in 3D spaces, and autopilot are typically successful in maintaining flight stability and landing and taking off autonomously. For flight range, most drone hold a small capacity energy unit, and drone energy consumptions depend on the numerous parameters such as flight conditions, weather conditions, and drone type. The second motivation of this research, it has come from the applications of the drone. So drones can be used in many of applications. Here is just limited, is not limited, but as examples is like delivery applications, as we are now in coronaviruses. Some companies or big companies that use the drone to deliver the products to the customers, like Amazon and also the postal mail. So another kind of application is agriculture and activity and construction activity and filming and augmented and virtual reality. Okay, and the most important now, which is the second my research now, research and work on it in my group, is fighting the COVID-19 epidemic. So by drone, we can use the camera, and the camera can detect the picture and imaging for any social community that, let's say, more than allowed number, let's say 10 or 20. So they can send the alarm for the police or for people that can send the police car to this kind of place and to try to control the place over there. This is one kind of application. Now I'm working on it. Okay. Also for the big problem in drone, it is the violated the data security and privacy of individual and present a risk to national institution and governments. And for this, some or many of governments use the authorization program. Regarding to the law of the drone, there are some internal law and external law or international law that make specific national authorities have implemented operating authorization program to ensure that commercial companies, for example, wishing to use drone or anyone wishing to explore new methods of using drone do so responsibly and securely. In Saudi Arabia, if you can give deeply to get my point, in Saudi Arabia, many acceptance models are developed for different technologies from user perspective, like mobile transactions and mobile government services. However, and based of my knowledge, there is no specific framework that already developed for adapting the drone from the perspective of the user. So, and this is the third motivation in my research. Regarding to the choosing what kind of modeling I'm gonna to adopt it and used, a summary of review several papers of theories and models that have done, and they classified the acceptance theories into two classifications, which are methods for development and method for scientific field. This is a figure shows the kind of two types of models. We are in my research, I'm looking for the method of development of adoptions, and here we have many of models, and based on the teacher view, and that we're going to show in next slide. I use the TAM2, which is extended from the TAM1. Why I'm used TAM2? I'm going to explain here. Maybe jump to this slide. So many models have developed, such as TAM1 and TAM2, but for TAM2 especially, it was developed in information technology field, which is like drone, what I'm gonna investigate now. So it has been extended from TAM, and also TAM2, based on many of researchers, claim that model is comprehensive because of containing a lot of constructs contributing to the acceptance behavior. Many studies showed many factors that should be considered when measuring the acceptance of technology in general, and in particular also in drone in some countries, like trust and attribution and privacy and competence and integrity and benevolence and operator. So what's the aim of this research? We are here in Saudi Arabia. We have a vision that conducted by the Prince Mohammed bin Salman, which is called Saudi Vision 2030. So the Saudi government goes to use the drone applications extensively based on the Saudi Vision 2030. And to achieve this objective, the General Authority of Civil Aviation launched its electronic services for licensing drone. Our question is to which extent the acceptance of technology drones from the user's perspective. So I have two questions, research questions that I'm looking to answer, I hope, once finishing my analysis and my discussions. The first question is that there is needed to know whether drones in Saudi Arabia is accepted by the user or not. And the second is there a desire to continue usage, which comes after the acceptance depends on the user satisfaction. I'm still in the second stage of this research. I need to do more analyzing for the survey that I did to find the factors that have strong relation to our models and to validate the framework. So this is here can show my framework is depending on the TAM2, and I included.
Sorry to interrupt.
Yep.
Sorry, I've got 2 minutes left to interrupt.
Yeah, I'm going to finish soon. I use the TAM2 and also include some attributes here. And now I'm going to investigate the significance of these attributes to the intention of using the drone in Saudi Arabia empirically and statistically. This is my future work. So there is need to validate the proposed framework to identify the factors that should have a significant impact on the intention to use of drone from user perspective, and also to validate a framework empirically and statistically. This kind of references I use to build this quick presentations. And thank you very much. And any questions?
If anyone has any questions, just write them in the chat box and I'll just say them. What kind of research methods will you use for the paper on drones?
Yeah, I used three kind of methods. First of all, I start by inductive research, or what I mean, it is like extensive literature review. After I found all the attributes that can be used to build our framework, I do the survey. Also, after I collect more attributes from the survey based on 1,100 users here in Saudi Arabia, I started the focus group. I sit with the expert in this domain, and I gave him the results I got from literature review and from the survey. And finally, they verified all the attributes for me, and I built the conceptual model. After that, I'm now trying to do more analysis, statistically analysis, particularly for these attributes, to find the significance, real significance between these attributes and my model. And in final version, I'm going to remove that any kind of attribute or factors that doesn't have like significant impact, and I will keep the other as a final framework for me. That's it.
Okay, thanks for that. Oh, were you not finished? No, okay, that's fine. So moving on now, we're now going to go to Milen, who will be presenting CSP machine in the standard C++ library context, implementation and sample applications. So Milen, when you're ready. I'll just ask you to unmute. I've just clicked unmute mic, so you just have to accept.
Yes, I'm ready.
Yeah, I can. Cool. When you're ready to share your screen.
Could you see my screen?
Yeah, I can see it. You're all good to go.
Thank you. Dear colleagues, thank you for the possibility to present to you part of my recent research. Leading methodological principle of science is to direct investigation to the essential contradiction of the subject domain. At the area of computer systems development, this is the contradiction between the explicit parallelism of current computer architectures and the sequential thinking. Coarse theory of communicating sequential processes, or CSP, is a strong basis for analysis and synthesis of concurrent computer systems. Therefore, CSP is one of the potential means of overcoming above-mentioned contradiction. The CSP model defines an abstract CSP machine which consists from two subsystems, computing nodes and communication medium. Computing nodes provide a protected execution environment for processes, and communication medium provides multiple channels for message passing. Over its history, CSP has found numerous implementations, but its constructive potential is far from being expanded. If the absence of protected address space is ignored, the C++ standard thread class could be regarded near close to CSP process semantics. But in the C++ standard library, there is not type even approximately close to CSP channel from one side, nor to CSP non-deterministic selection from another side. Hence, the main goal said to propose suitable implementation of the CSP semantics of inter-process communications through the C++ serial standard library. Means in seek a higher degree of structuring of communications of object of type standard thread and hiding of lawful level synchronization mechanism. Let's assume we have a parallel system as consisted of two processes, producer P and consumer Q, described by the CSP equation. Both processes P and Q form a communication pair, then interact over point-to-point communication channel. These channels are unidirectional, point-to-point, and buffered with direct naming, the simplest possible kind, but requires a special kind of bilateral synchronization known as rendezvous. In parallel system, from other hand as well as in congruent ones, non-determinism is an intrinsic feature and is a result of random choice of transitions. This transguarded comment is a mean to control the effective use of the non-determinism in parallel system. Guarded command evolved by Horing CSP alternative command equation 2. But special interest is the case when the guards are input command equation 3. Here is shown a simple example of a non-deterministic process. This is the receiver queue. In summary, semantics sigma of CSP inter-process communications could be generalized as tuple 5, where P is the pair of processes communicating over the channel C, using the pair of commands O over the channel, and R is the specific bilateral rendezvous synchronization. The communication channel is basic building block of the CSP machine's communication medium. Hence, the need for separate class CSP channel implemented in this library discussed. This class encapsulates channel descriptor, channel constructor, member function send, receive, and etc. Standard condition variable classes means for unilateral synchronization. So to construct bilateral synchronization needed, we have used two consecutive pairs, wait, notify, appropriate order in sender and receiver. With the above CSP channel implementation, we achieve cumulative effect. From one side, maximum proximity with the CSP semantics, from other encapsulation and hiding of low-level mechanism, and effectiveness near to the standard metrics class. Except communication scheme one-to-one provided with the CSP channel class, it's necessary to maintain N-to-1 communication scheme, and that in more general non-deterministic form, as have been shown earlier. Here at this slide is shown generalized operation structure of CSP metrics class function receiver, which ensures non-deterministic behavior of the construct. Several other known implementations are compared with this one. The communication schemes one-to-one and N-to-one supported by above discussed class channel and multiplexer are in principle sufficient to perform any possible type of inter-process communication, but from practical reasons, the additional two classes sync and fork are included in the CSP library implemented as well. CSP sync class implements equation shown here, and here all available inputs are executed in parallel and command ends after the last input received. Conversely, the fork class performs multiple waits by output, thus supporting the multicast send. Conclusions. Following the practice of the standard C++ template library is developed a compact CSP library encapsulating the means of messaging and synchronization between object of the type standard thread and in the same time hiding of low-level synchronization mechanisms. Testbed applications developed cover different types of interactions, scope procedures, active shared objects, implementation actors, etc. Both the CSP library developed and its testbeds include only standard constructions and hence are portable at source level for use with other C++ 11 and about compatible environments. The code developed library and examples are posted onto the GitHub repository under MIT license. Here shown several examples, co-procedures with decentralized management, distributed mutual exclusion with central server, active shared object, actually active mailbox here. Thank you for your attention.
Right, sorry, yeah.
I'm ready for questions.
Just write them in the chat box. Milas, do you have any questions? I'll just give him a second to write it out just in case he does. Right. Oh, no, okay, he doesn't have any questions. Right, thank you, Milan. We'll move on now.
Thank you.
Thank you very much. Right. Moving on now, we're going to go to Joseph Reyes Rojas. I believe he is in the call. Joseph, are you there?
Yes, present.
Okay, I'll stop sharing my screen and I'll let you.
Okay.
Yeah, whenever you're ready.
Yes, ready. Excuse me. Okay. Okay. Good afternoon, everyone. My name is José Leo Reyes Rojas. I am assistant engineering student from Universidad Privada del Norte. And today we're presenting the research entitled Analysis of the Impact on Virtual Teaching and Learning, and Review of the Scientific Literature from 2011 to 2020. Education has been evolving over the years along with technology, generating new teaching and learning styles that favor students and teachers. In recent years, the spread of COVID-19 has affected the lifestyle of people around the world, not only having a devastating impact on health, but also trending the continuity of education, casing the closure of universities and schools. This crisis has made it possible to see with greater importance the opportunity offered by technology, so they allow transforming the modality of face-to-face education into virtual education using ICT, which provide much flexibility with respect to space-time and health institutions to develop their functions more efficiently. The ICTs have managed to offer great possibilities in student learning, such as facilitating the search for information, helping in the development of problems, promote participation and teamwork, and contribute to increasing their knowledge and intellectual skills. Likewise, ICTs play an important role in teaching. They provide valuable resources for teachers' pedagogy, allowing them to be in contact with the students in a virtual environment, creating our activities in a didactic way by means of visual, interactive, and innovative aspects. However, the appropriate use of these tools implies that teachers must have different skills and knowledge that allow them to adapt to the new era. The use of ICT has allowed the development of different ways of carrying out the learning process, among which are associated collaborative learning, significant, cooperative, and autonomous, which are used effectively with the continuous guidance of teachers. The research answers the questions, what impact do ICT have on virtual teaching and learning, between the years 2011 to 2020, and what is the type of learning mostly used virtual education through ICT. Having as objective determine the impact of ICT on virtual teaching and learning between the years 2011 and 2020, and determine the type of learning mostly used in virtual education through ICT. Results. From the articles collected, it was possible to identify that 35 articles have been applied at 3 educational levels, where ICT for virtual teaching and learning have been evaluated and applied. Distributed as follows: 22 articles in higher education, 8 articles in secondary education, and 5 articles in primary education. We also found the advantages that ICTs have brought to both teachers and students for the improvement of education, as shown in the following table. It keeps the teacher constantly updated, and they provide didactic resources, they promote innovation and pedagogy, provides flexibility and distance and time, and facilitates the learning process. On the other hand, the benefits of use of ICT in virtual education can be observed since the following was obtained: improves academic performance, and generates good attitudes, and the motivate the student, and generate greater autonomy. Of the types of virtual tools, it's observed the tools for the exchange of ideas and experiences are the most used in comparison with the other tools. So they may use of blogs, wikis, forums, social networks, and video conferences as a means for virtual education. Then there are the information distribution tool that focus on the use of online platforms to share videos, audios, and books, followed by the application experimentation tools that are used in specific subjects such as mathematics and language. Finally, there are the assessment tool that use online platforms as a means to evaluate students, such as the Kahoot tool. On the other hand, of the types of learning applied in virtual education, it was identified that collaborative learning was the most used in virtual education with 53% of the articles. Then it was followed by the significant learning that was found in 21% of the articles, followed for cooperative learning that covered 16% of the articles, and finally autonomous learning that had 10% of the articles. Results responding to the first question, what impact do ICTs have on virtual teaching and learning between 2011 and 2020? In table two, it was highlighted that the use of ICTs provides great flexibility in education, so they have allowed to rate the varies of space and time in which classes are held, and have also facilitated learning of students due to the teaching resources they provide. On the other hand, the use of ICTs requires that teachers are constantly updating in the use of digital tools, because this will allow them to adapt to new teaching methodologies. Table 3 shows that learning through ICTs has provided great benefits in academic performance due to the use of various tools and that generate good attitudes and motivate students to continue learning. Table 4, it was identified that the tools for exchanging ideas and experiences were mostly used with 68%, since they allowed communication and collaborative work between students and teachers using wikis, blogs, social networks, video conferences, and forums. On the other hand, it was shown that the highest rate of use of ICT is reflected in the higher education level with 63%, due to the fact that teachers are more proper and have a rating infrastructure and technology. In addition, it was possible to answer the second research question: what is the type of learning mostly used in virtual education through ICT? In figure 3, it was shown that collaborative learning took among the other learning with a 53% preference, seeking encourage the participation of all the members of a group for the development of a certain work by performing different tasks, but with a common objective. Conclusion. Okay. Conclusion. The results, it was demonstrated that ICTs provide great advanced and virtual education with the flexibility and with the resources that on their students, strengthening their academic performance. In spite of this, and the limitation that was found to carry out the use of the ICT was that the teachers must be in constant update so that they can face the diverse challenges and that can tell the use of these tools. So they will be the people who will use it for the improvement of their pedagogy as well as guide the student in the effective use of these tools. On the other hand, it was possible to identify the types of learning associated with virtual education, among which the most outstanding was the use of collaborative work among students. Finally, for future research, where it's recommended to analyze in more detail the factors that prevent to change from traditional to virtual education and develop in underdeveloped countries of the world. Likewise, to identify the reasons why educational institutions do not make use for virtual education in its totality in the present 21st century. Yes.
Well, apologies there, my microphone wasn't working. So there's a couple of questions. So the first one is, oh, sorry, my laptop's playing up. So the first one is, what is the population of articles where samples were selected?
Please, no, Rotito.
You can read the questions in the chat box.
The articles is recollected the Dialnec, Redali Gorgi, Sajrek, and others. Equals, in the second question, okay. When the systematic review made it possible to show the importance that ICT have had between 2011 and 2020, noting that they are an essential tool for teaching and learning, which has generated new educational methodologies that are student learning and support the work of teachers. These have been integrated in a very gradual way in these institutions and in some cases in North. However, with the pandemic COVID-19, it was possible to give a greater value to these tools due to the benefits and advantages they have provided, among which stands out the variety of the didactic resources they provide and the flexibility and distance and time in which education is carried out. Allow it to show in this review that this benefit the students and their academic performance and generate good attitudes in the students. On the other hand, it was possible to observe the type of learning mostly used for the use of these tools, among which is collaborative learning that proved to be a good ally in the way in which learning is done, since it promoted the participation of students and carrying out their activities by performing different tasks, but with academic common goal, which must be shared by members, explaining and discussion and generating ideas to achieve the success of the objective. The research intends that virtual education with the use of ICT is not only a tool to be used in emergency situations that arise in the country, but also to see the possibilities they offer in education, giving them the opportunity to make a change to the traditional education to which they're accustomed.
Okay, so thank you very much for that. So now just moving on, we are now going to go to, what's going on here? Oh, I'm not even sharing that. Oh yeah, sorry about that. Right, so now moving on, we're going to go to Alberto Arteta, who is going to present on maximizing parallelism in the cloud, a hybrid load balancing approach. So I'll hand over to you now, Alberto, if you're ready.
I am ready. Can you hear me?
Yeah, I can hear you just fine.
All right, I'm gonna share my PowerPoint. So just please let me know. You can just see.
Yeah, I can see it.
All right, perfect. Way to go. All right, good morning, everyone. Good afternoon. I'm here in US, so here is morning, 6 hours back. Today I'm gonna speak about one recent issue that we had with our students. We have a lab, and in this lab we were studying the parallelism to simulate a cloud environment, and we focus on the load balancing techniques. Right. So what we're gonna see today is just 20 slides of the highlight that is gonna highlight all the work that we did in the last semester in the lab with this simulation in the cloud of the load balancing approaches. All right. So so what we know is when we have a high number of processes, right, that require CPU that is higher than the number of cores in a virtual system, achieving a full degree of parallelism is hard. Okay, so load balancing approaches are essential to try to reduce and try to minimize the cost of having such environments. So what we have been focusing is in an optimal load balancing strategy that can increase the multi-parameter.
Alberto, sorry to interrupt. The last few seconds, the screen's just turned white.
Oh, I'm sorry.
I can't see anything.
So you don't see the slides right now?
No, I was originally, but not anymore. If you maybe, I don't know, just stop sharing and share again. I'm not too sure. Yeah, someone else just said they can't see it either.
Okay.
Maybe, yeah, perhaps if you just like stop sharing and then share again. Too sure,
you are screen sharing. Okay, so stop share and then.
Yeah. I mean, I suppose so. It's
Okay.
worth a try. It was sharing originally.
Yeah, let me share it again. I'm sorry about that.
No, it's fine. Yeah, it's working again now.
Okay. So I'm sorry about that. Okay, so when the number of processes requiring CPU is higher than the number of core in the system, as I said before, then we have a problem. We have many more threads to handle. So we need to achieve parallelism. It's almost impossible it's practically impossible to achieve 100% of parallelism, but we can just have some approaches to try to reduce or try to increase the parallelism degree. Okay, so we're going to focus on a few approaches that we already know and then we'll be working on, and then our proposal, which is a mix of them, which is a hybrid approach, and then we'll discuss the results. Okay. Okay. All right, so we have the diagram shows that we have user requests, and then the requests are handled by the different kind of virtual systems. It can be cloud systems or any other virtualization, any other virtual system that we might have in our network. And then the load balancing approach, so the amount of requests are usually handled in two different ways, with static algorithms, right? Or with dynamic algorithms, static load balancing approaches or dynamic load balancing approaches. Okay, so the static use the average metrics to make the balancing decision operations. Those are decided beforehand, so the workload is not distributed in a smart way. Usually it just mainly is defined or is designed which node is going to take over, which is going to get the load, the income load of the income request. And then the dynamic load balancing approach, as we already know, they see how busy the nodes are, how well they're handling, and then they usually assign the load to the idle nodes, to the nodes that they are less busy, right? Okay, so this is an example of an static with using a typical round robin approach, in where, you know, the round robin has like an internal timer where assign task 1, then task 2, then task 3, task 4, based on a quantum period of time to different nodes, right? We already know that. And then an active monitoring based load balancing is, on the contrary, is more efficient because it's like the black box is the middle layer between the task and the nodes that are going to be able to handle the load. All right. So the two different approaches are the differences are clear. One is more complex than other, and add one more complex layer. But in terms of efficiency, the dynamic load balancing approach usually performs better when the amount of threads or amount of process are increasing, and then they are harder to manage by the nodes. Other example that we know is the ACO, is the ant colony optimization, which is designed for optimal load balancing. Then this is a biospire approach, in where the ants move towards the food provided from the top node, while the food is representing the workload, right? And then the ants just record their data for future decisions. Okay, so that's how the ants work, and that's the same algorithm, how the nodes are handled well in time, the threads and the processes, how well they're doing. So they record that in internal tables, and they focus on that table when they need to handle one thread of information of a process. All right, so our proposed method is going to be a hybrid approach. It's going to be a mix of static and dynamic. We're going to work on different characteristics of the static. Basically, we're going to add some priorities beforehand to the nodes, the ones that they are having better resources, like, you know, higher CPU, faster CPU, more memory, things like that. But we're also going to focus on the way that they are being handling the load. So we're going to store all the metrics that we need to determine how good a node is in terms of processing those threads of information, handling those user requests. Okay, and then we're going to keep that in a dynamic table that they're going to use those metrics. So they're going to be storing those metrics for another method that is going to look into that to determine which node it has the highest priority. Okay, so there's going to be a list stored in memory with priorities of nodes based on basically CPU performance, weights and availability. Of course, a node, even if he doesn't have enough resources, or he doesn't have you know, like a good CPU or a big amount of memory, but it's idle, it doesn't have any workload at that moment, of course that is going to have the priority. All right, so we're going to take into account, you know, in every time unit, the availability, the CPU performance, the amount of resources, and the time that a node has been idle, and the amount of threads per node. Okay, so those counters are going to be measured, and they're going to compose like a function. The function is going to be the priority of that node. Okay, so in the table, we're going to keep the priority of the node. The top of the table, the number one record in the table is going to be the highest priority, and the one in the bottom, it will have the lowest. Okay, so when all priorities are equal, then we say that the servers are going to receive balanced traffic. So we're going to talk about static balancer. Okay, so this dynamic approach, initially it was like static, but when the workload comes in, then it becomes dynamic. So it take into account all those metrics I just talked about. All right, so the algorithm is very simple. I just included in pseudocode here. So when the number of system process or threads are greater than a threshold that we call K, then what we do is a for loop in where we just check each node. For each node, we calculate the availability, we calculate the weight based on the time that has been idle or busy. We calculate the priority, and then with all those priorities, we calculate the max priority and then distribute the load to that node. Okay, so it's very simple, it's very straightforward technique. The difficulty here, the complexity here is choosing the metrics, collecting the metrics, and then coming up with an right output. All right. So basically, this could be like a, like a screenshot of what we are doing. We have the user request that just creates threads or processes in the operating system, in the virtual operating system. The operating system just look into the operating system just handle the load balancer. The load balancer look into the tables that they just check the availability and the priority, and then those, based on the table, it assign the task, it assign the workload to the virtual nodes. Okay, virtual nodes of the cloud. That behind we have the physical nodes that we don't really care about the physical nodes. We're just working with the virtual nodes like any cloud system. All right, so again, we have like this flowchart where we have user and client requests. We have this request to the load balancer. The load balancer search for the priority in the table, search for the availability. That availability is part of the priority, but of course, if one node is available, then and has a high priority, then that's what's going to be assigned. We assign the request user, and then the virtual manager, the virtual node, process the user request. All right, so based with this approach, then we had this idea of combining these techniques and focusing on these main metrics, which seems to be very straightforward. We just compare, we simulate the results of this approach with others that we already know, like the ACO or round robin technique or the wide round robin. So we propose our proposal, and the traditional algorithms have been compared in environment that we had. In this environment, we have 3 cluster nodes and a distributed operating system. The 3 nodes were virtualized, simulating the load balancing model as it was in a cloud system. The data collector has been, the data collector of the operating system was recording the latencies and other performance metrics for the implementation. So that was our main source of information, the data collector working all the time just to see the metrics of these approaches. So the virtual cluster was logging the activity of every node. Oops. Sorry. Stuck. I'm sorry, I went to the wrong. I don't want to touch many things because I don't want to mess it again.
We've only got a minute or 2 left.
Okay, yes, let's go. It was stuck for a second. Got it. Sorry, thank you. So the virtual cluster was logging the activity of every node in the virtual node that we're talking about. So we have one node that we're just logging all the activities. We have a daemon process that was running, generating system calls and creating processes in every node, asking for different resources like memory or system calls or like printer, whatever. Those services were switching from terminal, printer requests, hard disk, USB units, was randomly selected trying to overload the system with process greater than a prefix threshold. All right, so with this scenario, I'm going to show you just the metrics. We normalize those metrics from, from the, we normalize the results that we obtain by applying our technique. So the metrics that we focus on after just using, after comparing, our approach and the traditional ones. Remember that our approach is focused on other metrics, the metrics that data collector gets from the system. You just get those metrics, insert those in the table, and then our approach focus on the table, okay? So those were one metrics, and then we have other metrics, the metrics that we use to measure how good our approach is, okay? The metrics are gonna be defined as the process per unit of time, average threads per core, the car flat metric that we already know when we talk about parallelism degree in any system, the average response time for a given thread, and the parallelism degree that is defined, so you probably already know, defining the Atlas law. Okay, those metrics were normalized just to show the proper display. We normalize those metrics in values between 0 and 1. We use the min-max scalar function. All right, so the first table is just show, this is a snapshot of the normalized metric with a stable variation of threads. Okay, so what we wanted to show here is these metrics that we were just talking about, the amount of threads per CPU, the average threads per core, the car flap metric, and the parallelism degree. They were normalized when the number of threads were stable. So pretty much when the system was not overloaded, right? So there were like maybe one node where were like were busy and the other nodes were not busy. So basically when the system can handle the user request very well. So you see then the ACO was, when we talk about the average of all those metrics, we just have an average just to give you an idea. You see that there's not much difference between all of them. Then you see like maybe the A and B algorithm, the way round robin. I mean, all of them, they were well. Our method, which is the hybrid, it doesn't contribute that much. That variation is not very different from the others. But then when we talk about, an increase of threads when we are trying to overload the system, here you see this in this table we are increasing. And this is a snapshot of normalized metrics with a dramatic increase of threads. Is then when the algorithm with the load balancing needs to be more accurate, and then trying to assign the node that is expected to behave better and to handle the thread of the process faster. Okay, so then when we compare this, you see our average approach, it has an average of 0.497, and yes, slightly better in terms of handling the request. Okay, so that is something that in our simulation it gives us, kind of good information about to implement this in a real cloud system. I can also show like the graphics. I would like to show you. I would like to share here the graph. Then in the graph we include a new metric. This combined that it was part of the data collector. Data collector, it was designed to collect many things, latencies, all kind of latencies, all kind of times. Apart from the ones that we have. And then we wanted to combine that into one metric, which I wanted to display. So let me just show it to you, this comparison in this graph, that we have the ACO, the A and B, the weight robin, and the static load balancing, and our approach. So here you see our approach is black circles, right? SLB are squares, weight round robin and star. So our approach here, the hybrid approach is black circles, right? So the black circles here, when we compare, you see most.
Sorry to interrupt you. You need to wrap up soon, mate.
Okay, I'm finishing now. I'm results. Okay,
yeah, you've got.
You see the.
So I'll give you a minute. So. Yeah, that's fine.
I'm just resolving and then concluding the next one. So I'm finishing. Thank you.
Yeah, that's fine.
All right, so we have the average here. So you see the combined metrics. All right, so, well, you see the results that we have, that the black circle down, you just prove, and it just shows that our approaches can really work in a real environment, because what it does is just, just reduce the amount of load, the amount of handling requests by these nodes. Okay, as a conclusion, and that's the last slide. We know that optimal algorithms for load balancing to distribute dynamic workload is essential in cloud computing or any other virtualized system. We also know that this paper has focused on static, dynamic, and also a combination of them. Okay, so that's what we mentioned of them. Sorry for the typo. All of them aim for maximum resource utilization and reduce response time. Of course, that's the key of these approaches. The proposed algorithm shows a virtual manager node considering the system resources and their availability to increase the throughput, okay, to reduce or to reduce the latency, of course. Simulations have good results in comparison with known approach, and apart from availability, reliability is also one of the critical factors for cloud computing. This was not really tried in our lab. We don't know how it's going to behave in the future, how reliable would it be, how stable it is. This is just a simulation in the lab. Even the results are promising, we still will need, a macro system, right, to try it on. Ideally, this algorithm could be tested in a real cloud provider environment, but that's pretty much all.
Right, if anyone has any questions, please just put them in the chat box. We'll just give it a second. Milas, did you have any questions you wanted to ask? I'll just give it a second. No, okay. Right, thank you for that, Alberto. So now,
thank you.
We're going to return to Miss McCalmer in the hope that her presentation is now working. So, Miss, if you'd like to try again, I've requested to unmute
Yes.
you.
Let me try again.
Yeah, good luck. Well, I hope it works this time. Yep, there you go.
You see
we can see it.
Okay. Yeah. Good evening, everyone. My name is Nozwelo. I'll be presenting the user experience framework for teachers using mobile technologies in resource-constrained environments. This was done by myself and in collaboration with Dr. Van Steyden and Professor Botha. The important keywords for this study is the user experience, mobile technology, context, resource constraints, environment, user experience, components, teachers, ICT in education. And for the introduction, the use of information and communication technology has emerged globally. The occurrence of the ICT is believed to have influenced the development of the society, including schooling. Internet and mobile technologies are considered ICT tools, making it possible for schools to access e-education using mobile technologies in teaching and learning anywhere, anytime. Access to technology in school is not only limited to urban schools. It also includes the schools located in rural areas. Education has the potential to improve development in rural areas, hence the importance of education transformation in rural schools. Rural schools are based in rural environments and are considered to be resource-constrained environments because they often lack proper road infrastructure, have low connectivity, market growth is very low, and have a low income. Further limitations include limited access to electricity, low levels of literacy, a lack of infrastructure, lack of technology, and technical constraints, all of which require people to be innovative. There's a challenge in adoption of the use of technology in schools, compounded by the lack of infrastructure, shortage of qualified teachers capable to use the technology, technophobic teachers, and lack of experienced teachers in using technologies for teaching and learning. As mobile technology becomes increasingly used in schools and teachers are expected to conduct teaching and learning in the classrooms using mobile technologies, it is important to ensure that teachers are comfortable with using mobile technologies and that the user experience of the teachers using mobile technologies is enhanced. Negative user experiences have been reported and have led to limited participation and engagement, resulting in the ineffective utilization of the expected pedagogical gains and organizational benefits, as well as abandonment of using technologies. As a result, it is suggested that the UX or the user experience of the teachers be acknowledged in order to provide an optimal learning environment. It is against this backdrop that the following research questions have been identified. What are the components and factors of user experience that are relevant to teachers using mobile technologies in resource-constrained environment? This research explored the user experience of teachers using mobile technologies in resource-constrained environments in Gauteng, Northwest, and Limpopo, where the ICT 4E project was implemented in rural schools. The next slides will present the literature review, research methodology, and the findings in an attempt to answer the research question. In 2016, the South Africa's Council for Scientific and Industrial Research.
Your slides haven't changed. It's still on the first slide. I thought I'd just let you know. It's not coming up on mine anyway.
It's not fine. Can you see it?
It's still just showing the first slide. It was just you said you were going to slide and then it hasn't on my screen. That's all.
Can I stop sharing and?
Yeah, I don't know if it's the same for anyone else.
Okay. Okay. Can you see this part now?
It hasn't started sharing for yourself on mine anyway.
Share screen. Application. And share. Is it fine now?
It's still on the first screen for me. I'm not sure about anyone else.
Can you all confirm if you can see the next screen that I'm sharing now currently? It reads literature review.
Oh yeah, no, it is now, yeah. It's on the literature review page now.
Okay, can I continue here?
Yeah, sorry about that. I just thought about
okay. In 2016, the South Africa's Council for Scientific and Industrial Research signed an agreement with the Department of Rural Development and Land Reform for the implementation of the Information, Communication and Technology for Education project in rural schools, with the aim of incorporating the use of mobile technology in teaching and learning. The project was implemented to 24 schools in 7 of the 9 provinces in South Africa. The provinces included Limpopo, Gauteng, and Northwest, which is what we're focusing on this study. The IDEA lab at the University of Free State was appointed to facilitate the training of teachers through a short learning program known as the Teacher Professional Development course. The course included skills, knowledge, and strategy improvement in ICT, in ICT, where teachers were trained to use mobile technologies in teaching and learning and were awarded certificates for completing the course. Training teachers to use mobile technology in the classroom is important, and therefore teachers are expected to apply their technical skills effectively when using the mobile technology at schools. The user experience of teachers who participated in the ICT 4E needs to be evaluated with an intention to identify factors that may have an influence in the use of mobile technologies in resource-constrained environment. The following topics are covered in the literature section. The conceptualization of UX, which is the user experience, exploring the UX components, the user system and context components.
Sorry to interrupt, because I think this question kind of needs answering now. Melise asked, please clarify, what do you mean by mobile technologies?
What do I mean by mobile technologies?
Yeah, it just seemed like a question that probably needed answering now so we can understand it a bit more.
Mobile technologies include devices like your phone, your tablet, your PC. I think, yeah, that's the way to explain what the mobile technology is. It's the use of the mobile devices.
Okay, continue, sorry.
Can I continue?
Yes, sorry.
Okay. User experience provides factors that are used to determine the UX of the user, such as emotions, attitude, perception, user expectations. As the teachers apply their skills in using mobile technology in the classroom, one should also take into consideration the beliefs, the attitude, and the anxiety levels of teachers when integrating with mobile technology into their classrooms. UX is a distinctive concept, as it can be explored based on what the researcher wants to focus on. As to date, there's no agreement on the definition of UX, as it is viewed from different perspectives because each product or system may have different goals of UX. User experience is defined as a degree of positive or negative emotions that can be experienced by a specific user in a specific context during and after product use that motivates for further usage. It is described as a person, perception, and response resulting from the use and or anticipated use of the product or system or service. The concept of UX is known to have several different definitions by various researchers. These definitions share common denominators which were identified as the components. They are namely the user, the system, and the environment or the context. The concept of UX is simplified as being used to evaluate the effectiveness and efficiency of a system through the user's feedback by way of emotions, their behavior, their attitude, expectations, and perception about the system. This study adopted the definition which states that characteristics such as perception, emotions, attitude, behavior, expectations are incorporated when users interact with the system, which results in a user experience being performed. In general, UX is about evaluating the system through the user's feedback when interacting or after interacting with the system. Here we are exploring the UX components. Every system is designed for different purposes, hence the UX in all systems may also differ. As a result, the components of each system may differ depending on the purpose of the system. A component is defined as any element of context to combine previously used terms of vectors, components, dimension, aspects, state, and environment to under same umbrella. UX factor can be used to describe the situation in which a person felt a particular user experience. For the purpose of this study, the word components will be used as defined above, and factors will be used to be referred as a subcomponent. Various literature have been identified through UX components, and this table shows the identified components from different authors or researchers. So it's identified the components, and these are the factors linked to the components. So I cannot go through this because of time. Table 2 shows the implicitly identified components, which is also linked to the factors, but this one it's implicit. The first one was explicitly. It's explicitly because it was evaluated, or it was taken from the frameworks, and this one was through the work that is presented from the literature.
Okay. Apologies, you've only got a minute or so left.
Sorry?
You've only got a minute or so left.
I can hardly hear you. Can you please repeat that one?
You've only got a minute or so left.
Okay, so I will go straight out because the next screen is discussing the summary of the conceptual framework constructed from from various literatures. These are the components that were identified. These are the sub-components that were identified from the literature. The next slide shows the research methodology that was used. We use explorative qualitative research and qualitative method to gather the data. We use a questionnaire. It was open and closed-ended questions. 4 experts in the UX environment were used to evaluate the questions if they were understandable, transparent, and equitable for the participants. The questionnaire consisted of 4 sections, where the first section was a demographic. The second was related to the user factors. The third one was system factors, and the fourth one was context factors. A 5-point Likert scale was used to evaluate the teachers, and the target was 44, but only 30 responded, and 3 were spoiled, and 27 were analyzed. Thematic analysis was used to analyze the data using the Atlas TI tool, where codes and themes were used to produce the network diagram in evaluating or testing the literature and questionnaire of the study. The next slide shows the results of the participants and the identified factors, where they also, you can see somewhere where it says there's somewhere where they disagree with the findings. Like for instance, here it says gender doesn't influence the experience of the teachers. The age doesn't influence the use of technology at school. There's also somewhere where they say problem-solving skills, it's not required to work on technical tasks. There's somewhere where they also mention that multitasking doesn't have an influence. So in summing up, factors which didn't have an influence were eliminated from the revised conceptual framework, which was produced at the end. This is the conceptual framework which was produced at the end after the teachers have identified some of the factors which they thought they do have an influence in the user experience of the teachers. You can see the teachers, these are the factors here: the needs, perception, attitude, expectation, experience. Under the system, you get your usability, functionality, credibility, valuability, flexibility of the system. It's important. The quality of the qualified teachers, technological skills, and under context you can see your lack of policy implementation, the training. So in conclusion, it is without a doubt that the use of mobile technology at school is improving and transforming the learning process in education, and it is embraced by both teachers and learners. However, the use of technology cannot be fully implemented and adopted in schools if the user experience of the teacher or learners is negative. The research to examine the UX of a teacher is necessary, and the conceptual framework is significant in the field of study. It will assist the researchers who are interested in understanding the factors that may have an influence in the use of mobile technologies in schools in resource-constrained environment. Thank you.
Thank you for that. Did we have any more questions? Oh yeah, we've got one here. So I'll just read it out for you quickly. Can you hear me okay?
I can hear you.
Yeah, okay. Which mobile devices are primarily used in classrooms of resource-constrained environments? Considering resource constraints, some of them may not be available as they are too expensive. If you didn't hear me properly, the question is in the chat.
Okay. Specifically for this one, they used the tablets because for this project, the tablets were given to the schools who participated in the ICT 4E project. So yeah, specifically for this one, they used the tablets.
Okay, thanks for that. So that is all of our that's all of our presentations for today. So quickly, what I'm going to do is I'm just going to say a few words like I did in the beginning. So I'm just going to say a few words and then quickly I'll get you all to turn your cameras on just so I can take a picture for our website. So very quickly, I sincerely thank all of our authors for their excellent presentation and contribution in this session, and all our participants for being part of the International Congress. I hope this session was informative and knowledgeable as well. All the presenters will be getting their digital certificates through mail within 2 working days. Further, all of the papers have already been forwarded to the Springer. Publication will be live in 4 to 6 months. I also thank our session chair, which I apologise I have not. Sorry about this. Sorry, 1 second. Right, sorry about that. I would also like to thank our session chair, Milas Kitting, who unfortunately they couldn't properly interact with yourselves because of technical issues. But Milas, this is just a token of our appreciation, just to say thank you on behalf of the team at ICICT 2021 and Global Knowledge Research Foundation. Thank you for your help today. Just quickly, before you all leave, if I could quickly get all of you to turn your cameras on, just so I could take a screenshot, because we're going to put it on the website. Come on, guys, cameras on, please. No one's feeling it. Come on, guys, I've seen you already. I know you've got them. No, okay. I'll try my best. Oh yeah, okay, Milas is back. Oh, another one. Oh no, he's gone. All right, okay, I'll quickly take one. All right, thanks guys. Thanks a lot. Cheers, bye-bye.